much for rejoining the event. So as kindly introduced by the two gentlemen, my name is Mario van der Velde, my colleague Nico. We both are today working at the Blue Guide EMC lab. I don't know if somebody already Googled the name, but if you take a picture of the QR code, you will find more information. We mainly focus on the certification of electronic equipment, mainly for the European market, for the American market, but we also like to help our customers, and we provide some training. Therefore, we are also here to share our knowledge. Nico will share his knowledge with you. And finally, the goal is to get our customers' product safely on the market. The topic of today, EMC and the common pitfalls. I guess a lot of people here in the audience are engineers or somewhat technical, seeing the topics of today. So the first thing that we did while preparing our presentation is, as I assume everybody is doing, go to Google and search for EMC and pitfalls. And this was the picture that popped up. So I guess there are some people that are looking for pitfalls and are curious about EMC. So we thought, yes, maybe that's a good topic to talk about. So we would like to make it, let's say, easy for you, share knowledge. There's time for questions. So we prepared about 500 slides, so no issue there. We have all the time. The first thing that we will do is first an introduction. If somebody is not familiar with EMC, I assume not, but why, when, and how. Small introduction. And then Nico will pick up a case of one of our customers to make it concrete. Nico will do the introduction of our customer, where we encountered some pitfalls that we found that are regularly occurring during EMC testing, during certification. So we will have a practical approach, go through the case, share our knowledge with you, and at the end give you some, let's say, 5-6 pitfalls that you can avoid by applying some knowledge that Nico gladly will share with you.
Thank you.
Here's your stick.
Thank you.
Do your thing.
Welcome everyone. By the way, I use ChatGPT for all my slides. Okay, so we continue with the presentation. So why would you consider EMC? It's basically because it's regulated by the laws, and for the guys, the engineers who go into the gray zones, do not want to obey by the law. It's really important to obey according to EMC, because if you export your product, your importer will always or most likely ask for a declaration of conformity. Also, EMC is important because you don't want your product to fail when it's, for example, next to a laptop, so performance matters. And also, many clients, they will only buy from you if you have a certified product. So that's why it's really important to consider electromagnetic compatibility. When should you consider EMC? Most engineers or product developers say, okay, we're going to build this product from scratch. The certification we do in the end. But you should actually take it, once you have the concept in mind, you should already start looking at what regulations you apply to my product, because you don't want to come to surprises when your product is finished and you already have 1,000 of products in stock, and then you notice some kind of compliance error. And there are actually other stages where it's important, not only at the concept, but at the prototyping stage. So you can already do some basic testing to see if your final product will actually pass the EMC tests. And even after the compliance test, after the product is on the market, you should regularly confirm that it's compliant with the regulations. Because, for example, some kind of plastic is not available, which influences somehow the radiation, internal radiation, and you replace it, but you forget, but then somehow it has an impact on the electromagnetic compatibility. And that's why many manufacturers perform a conformity of production. So each year, they regularly test one sample out of their production line. They do some 1 or 2 type of tests to see if it's still compliant with the regulations. And also, when you do modification on the product, you should always check, for example, if you change one component inside, which could have impacts on the performance regarding to electromagnetic compatibility. When you have doubts, you should always consider retesting it. So there are actually 5 stages where you should take into account EMC. But of course, at the production, after it leaves the production line, it's mandatory that, of course, you have a report and declaration of conformity. But the other timelines are also important. Where can you test for EMC? Actually, you can do it at your own engineering department, but yeah, you cannot, when there are some kind of issues on the market, you don't have like proof it's actually performed well. So that's why you should go to an accredited EMC lab. So our lab at BGMC is accredited for many product norms. So in that way, you ensure your product is always compliant with the directives. So how do you start? For example, some of you maybe have seen it, the Albert's smoothie machine, which is currently on the market. So what does the Albert smoothie machine do? It provides healthy smoothies with the use of robotics technology and electronics. And of course, it has to be certified. And actually, Albert's equipment came to our lab. And when it's going to our lab, they asked, okay, how can we demonstrate compliance? So left in blue, you can see our EMC laboratory, red the manufacturer, and green are the concerned bodies. So how do they prove their compliance? It's just by one simple paper, a signed declaration of conformity, but it has to be backed up by the tests on the left, which is done by our EMC laboratory. So Alberts has given us the product definition. It's intended to use in a ref environment, and we match those specifications with product norms which are applicable. Then we do the compliance testing, and we do the reporting, and based on that, they build their technical construction file, and that's backing up their declaration of conformity. Now you're asking, who can ask your declaration of conformity? Mainly your customers, but also market surveillance. So for example, when they have some suspicion something is wrong with your product, the market surveillance, in Belgium it's called the Belgium Institute of Postal and Telecommunications, the BIBT, so they can ask for the declaration of conformity. So that's the main criteria. If you put CE label on your product, you should always back it up with a signed declaration of conformity, which is again backed up by our reports from the BGMC lab. So which products standards is applicable to the Alberts one? For immunity, so the products should operate normally when it's being disturbed. It's the EN 61000-6-1. There are a lot, and that standard is actually referring to a lot of basic tests. I won't go into detail about that for now, but you can see on the left there's a port under test, so it's mainly the enclosure or some kind of cable. Then we put some tests on that port, and on the right column you see the test parameters. So that's an overview of all immunity tests that are applicable. But for example, if you don't have a DC port, for example, Albert's, it's mainly powered by AC, so many of those tests are actually not applicable. There are also, Albert's one has to comply with the emission standards, and for emission is the EN 61000-6-3. So those are all type of tests. Also port under test, the basic standards we perform on that port. And for emission, there's actually a limit, as has been told by Mark from Agoria. We take, for example, it's being powered by the AC mains, conducted emission, according to that standard, and class B, so it's the first line, and we will look into that into more detail. So conducted emissions, if you read the standards on conducted emissions, left you see what's inside the standard. So the red circle depicts the device under test or the equipment under test. And then the blue circle depicts actually our equipment we put in between the mains line, and the Albert's one has also an Ethernet connection. That's depicted by the green circle. So left you see according to the standards, this is generalized formulation, and right you see it in practice. So the Albert's one EUT again in red. The blue circle depicts our artificial mains network we put in place to supply power to the Albert's one. And in green, it's actually the same, but then for the Ethernet connection. So that's actually the setup. I won't go into detail about the whole procedure, but this is actually the test results when the Albert's one came into our lab. They said, product is finished, we want certification. We do the first test, and what do we see? The green lines is the spectrum from 150 kilohertz to 30 megahertz. We measure on conducted emissions. And on the y-axis, you see the level in dB microvolts. And the green line depicts the average limit line, and the red line depicts the quasi-peak limit line. Of course, everyone can see that's way above a limit. And actually, it's actually kind of worse because on the y-axis, it's in dB, so it's a logarithmic scale. So if you have, for example, 40 dB above limit, it actually means it's like 100 times above the limit line. So it was, we were actually surprised about this result. So they probably broke our record.
We must admit this is not always the case, so don't be afraid to come to the lab. Actually, we selected a beautiful product, but the first test wasn't that beautiful. Huh? That's the main summary. But now we come to the pitfall.
We come to
that's a good thing.
So actually, conducted emissions was failing. So what do we do? Then you have to find out what's causing the problem. So there were, my colleague was performing the tests, and there were some guys from Albert's accompanying the tests. And after test 13, they found out that with a filter and no actuators disconnected, the freezer off, the payment terminal on, all electronics on, and no movement of the robotics, they finally got this result. But of course, you cannot sell an equipment like this with this type of functionality. But it actually gave them some insights. Sorry. Let me go back. So this was actually diagnostic information they could use later on to improve the product. So we sent them back home. They did their homework, and they came again. So left was the first iteration. On the right, you see the second time, and it's actually now it's more realistic what we see in the lab. So it's still failing, but not 100 times above the limit. But there's still some work to do. So they did again some testing and some diagnostics. And with the help of some EMC consultants, they finally got to the right, the EMC pass. So as you can see, the above green measurement result was below the red, and the below green measurement curve was below the blue. So that actually passed, finally, the conducted emission test. So that was for one test, but you have to take in a course there are many other emission tests. So they had a lot of work to do. But at least we can say in this presentation, it has passed the conducted emission test on the AC power port. Now, what was the main problem? Like I told at the start of this presentation, they developed the product, and at the end they said, okay, now we go for certification. So it's really important, even if you only have half of the equipment ready, that you start doing some pre-compliance. Because most likely, if you see half of your equipment is not according to the emission standards, then it's more likely that in the final product it will also fail. So it's really important, even it doesn't have to be final, but pre-compliance testing is really a lot of time overlooked, but it's really important. So it saves time, but also costs, because they had to come a lot in our labs, and EMC labs, as most likely you know, we are not that we're not that expensive. Yes, exactly.
As an engineer, I'm the manager, so I try to.
So you have the cost for redesigning the equipment, and you have the cost for retesting. And also, we had some cases, they actually had a lot of in stock, some not to Alberts, but some other manufacturer, and they had to do some post fixes, which can also be costly. So that was emission, and like I told, there's also immunity standards to comply to. So the Alberts one, it should continue to work. So if you want to have a smoothie and you carry your phone with you and you're calling, you don't want the smoothie machine to somehow stop dispensing smoothies. So for example, there are many immunity standards to comply to. But let's have a look at the one I depicted in the blue dashed box. So on signal ports, the standard says when your cable is longer than 3 meters, fast ranges should be applied according to the EN 6100-4-4, and it should be the test level should be 500 volts and 5 kilohertz. Nobody understands, but luckily we understand.
If you do understand, please contact me. We people that understand it, and explain me, because I don't understand either. So feel normal.
So what we ask our client is, we see that according to that immunity standard, it has to, when the cable is longer than 3 meters, the test should be applied. The cable in this case is the Ethernet cable. So a normal question is, we ask the one which is accompanying the test from Albers, is your Ethernet cable longer than 3 meters? Then they look at you, why do you ask? Well, actually, then the common reply is, if it's longer than 3 meters, we need to perform additional testing. And after a lot of discussions, nobody knows. So actually, in that case, we actually perform the test just to be sure, and they can state in the.
They help.
So
It's
Yeah.
yes,
It's a 3 meter
it's 3 meter cable.
Yeah.
Yeah. So in that case, you don't know where the equipment will actually be. Maybe it's close to a router to attach an Ethernet cable, maybe not. So anyway, we perform the test. So in that case, just to be sure, and when we say we perform the test, they actually hope the test will pass, of course. Because if the test doesn't pass, a lot of discussions can occur, and management will say, no, we will prescribe to not use a longer than 3 meter Ethernet cable, and that's always going to the gray zone. So we performed the test, and it was actually it passed the test. So here in the blue, you can actually see a screenshot from the standards that it's. Actually, if the test should be applied, if your signal cable, or in this case, the Ethernet cable is longer than 3 meters. So fast transient test, how is this performed? We have, let me see. So we have a clamp. We put the Ethernet cable inside the capacitive clamp. And then we capacitive couple 500 volt pulses with the frequency of 5 kilohertz. And then we actually monitor what the equipment is doing. So for that, what do we monitor? The standard says like this. It's quite theoretically, but it actually means that if it should actually perform like there is no immunity test present. So the smoothies the test cycles of the smoothies, the robotics, the test cycles, they program the test cycles inside the smoothie machine, and it should not be interrupted, and there should be no intentional movements. So if you apply the fast transient test on the Ethernet cable, there should be no suddenly smoothies being dispensed from the machine, which is logically. So Alberts 1 also passed that immunity test, and they can use any Ethernet cable length they want. Okay, let me go back. So we can put passed for this test too. Like emission, there are also many other type of tests to be performed on, which we have performed on the Alberts 1. So what was this pitfall? It's not actually a pitfall, but it's trying to avoid discussions in the lab. So it's really important that as much as information as possible relevant to EMC is provided from our lab or vice versa, from the manufacturer to our lab and from our lab to the manufacturer, to avoid any discussions. We had this was discussion about 3 meters Ethernet cable length, but there are also discussions, for example, when your clock frequencies inside your equipment under tests are above 108 megahertz, we need to perform also other additional tests, which can either pass or fail. So to solve that type of issues, discussions at the lab, we always provide an upfront information sheet. And you can fill in all your cables, your clock frequencies. What do you expect should be the normal performance? Can your performance degrade? So that's how we solve this type of issues. So the key points of this short presentation, the 2 pitfalls I talked about, that's really the importance of pre-compliance testing and providing all relevant information to our lab. There are also other pitfalls, for example, the applicable product standards, which RF environments. So for example, it's really a depiction between an industrial environment and a commercial environment. For example, a power supply which is used in industrial, For example, a power supply which has been compliant with industrial specifications and they put it in a commercial product, then somehow they can run into a lot of type of problems because emissions for industrial environment is less strict than for commercial environments. Other pitfalls are like, okay, we have different modules which are CE approved. We put them together and we assume it's also CE approved, which is mostly not the case. And there are many other pitfalls. And like any good movie, this is to be continued. Thank you for your attention. So my name is Nico, Mario. You can surf to our website if you want more information. And we also will be providing some webinars through our portal with respect to EMC. Thank you. I hope there are some questions.
In this case with Albert Swan, they didn't come to you before.
No, it was the first time they came to our lab.
So they finished their product and then they said...
Then they said, okay, go ahead, provide us a certificate, but don't say.
We had a small pre-compliance test at the site of the customer because, maybe it's not completely clear in the picture, but it's a very big machine. It's like a Coca-Cola machine. It weighs about 500 kilograms. So it wasn't easy to get that machine to our lab. So we went to the machine. We did some pre-compliance testing, maybe related to safety, but you need equipment and a full lab to measure the things that my colleague just mentioned. So what we learned and what we also mentioned to the customer, bring the machine to us so we could do some additional tests. But due to the size and the weight, the customer says, oh no, we will wait. But yeah, indeed, pre-compliance was a big issue here.
Are you allowed to elaborate a little further on how you solved the problem? Because it was massively above the limit. So can you explain a bit how you actually solved it to get it below the limit?
Well, actually, I cannot provide a lot of details, but it was mainly as I recall, the cabling and the power supply, which was passing through the emissions.
The power supply was not coming from Telerex. Thank you very much.
Yeah, but there were a lot of conducted emission sources and also the cabling at the first iteration, the cabling was not really. There was a lot of coupling between cabling, so they adjusted their cabling.
They rerouted a lot of
Yes.
cabling, and yeah, it was somewhat a mess at the beginning, and they changed it a lot. There was some. There's no silver bullet, Peter. We're familiar with each other. There's no silver bullet within engineering, so it's a lot of small things. But if you at the beginning see we're way above limit, then you can start working towards the limit, doing small things. But in this case, wiring of the cables, putting in additional things. I'm not a specialist, so but I observed the whole process. It was a process of several months.
But you got the customer helped out. So that's
Yes.
Yes.
To be honest, from our point of view, we are allowed to test products, but actually we are not. We are accredited, and so we are checked by BELAC. We are not allowed to give consulting or solve the issues. That we cannot do that. We give some tips, of course, but we cannot do that. So there are, let's say, partners that can do that kind of thing. And it's not the goal today, of course, to say Alberts. That's the big thing that they mismatched, and these are the steps. It's still a customer, so.
Yeah, but only the end result stay compliant. So, yeah. Are there any more questions?
The device under test, should that be in a normal use case or worst case use case?
It should be what you think will be worst case. So, for example, in this case, there was a test cyclist being programmed inside the device. So that's actually more worse than normal use. They were actually like dispensing, I'm saying maybe 5 smoothies per minute, for example. So they actually did the whole test cycle as being worst case. So if they change the firmware, it will still comply.
Because the test will take a lot of time. For example, if you have a coffee machine, it only takes a few seconds and the coffee is ready and you're meanwhile testing, but then it's gone already. So.
Yeah,
That's a good point. We always. Yes, so he was saying, for example, a coffee machine, you only use it like one time. But in that case, if you just put the coffee machine inside an anechoic chamber, and you will of course measure nothing. So, and it should actually always comply. So what many manufacturers do, they build in a test cyclist, which they exercise all the functionality. And if it's then compliant, you can be assured it will be compliant with any type of steering or sensors being read out. So that's the way how they.
That's
prove they
also
are
a thing
compliant.
you think of upfront. So you are able to program some kind of a test cycle inside your equipment, because if you come to the lab and how can you do these cycles during several hours, in fact.
Yes.
If the equipment is dead, then eventually, nothing will fail, if nothing is happening. So it's a good question. So it's worst case, and find a kind of a demo mode of.
Exactly. Yes.
If we take, for instance, a battery system, so it works in 2 different modes, okay? And we cannot combine both modes at the same time. The charge is already discharged.
Yes.
We test that.
Both modes.
Both modes. So this means that you
Separate.
have to apply 2 tests.
Exactly. So it's also in our good remark. It's also in our upfront information sheet where you describe your modes. So in that case, charging or discharging. They should, of course, both comply. Any other questions.
Could you share what's the average, not your case you showed here, but what's the average delay usually in the industry scene when the customer comes to you, they say, we're ready, this is our beta version, run it?
There are always exceptions on the top and exceptions on the bottom. Now, to be honest, we use a case where we can say something, telling everything went fine, no worries. That doesn't make sense. But gut feeling, I would say that 70-80% of the products go through the EMC testing, depending on the complexity, of course. That's a complex machine. But because testing is typically done at the end of the cycle, a month before they would like to put the product on the market, a month is really short. It's not only EMC, but typically it's also safety testing. So, and first you do EMC. If you pass the EMC, then you do safety testing, because EMC is complexer and has more chance of failing, and then you do the safety testing. So you have at least a throughput time of 1 month from thinking about it to be able to get the certification. So therefore, again, try to do it as soon as possible in your pipeline, in your stages of product development.
Yes?
What is the biggest machine that you can test? They build machines for 10 meters long?
The standard actually prescribes some limits, and there are also some practical limits. So, for example, for the radiate emission test, we have some kind of turntable which turns around. If you would put the big equipment on it, we would have to be really being creative to turn that big equipment around.
There are actually 2 parameters that will determine if you can test the product inside the lab, independent of our lab or another lab. You have a room where you do the test, so you have a door. So in our case, the limit of the door, it's let's say a normal door, 1 meter 80, 90. So if you have one dimension of 90, you can put it inside the chamber. That's one. Get it inside the chamber. That's one. And 2, make sure that the floor doesn't collapse. So weight is a second factor. So in our case, you have to have one dimension that's lower than 90 centimeters, I guess.
Yeah, around
something like that.
approximately 1 meter, I think.
Okay, well, I'm always cautious. And weight, this smoothie machine just fitted in our room by removing the cap. And this machine is about 500 kilograms. 500 kilograms is
just the limit what we could.
Depending on, I'm able to allow about 800 kilograms, but then I say no for safety reasons.
Can you do it on site? Some tests?
Yeah, maybe the conductor test, but like radiate emissions, it will be really hard to distinguish between other radiating sources. So that's always a challenge.
Everything that's inside the chamber where you absorb all the radiation, you need a chamber. Also what's to do with emission, let's say, radiation,
yes.
You need a chamber to put it in. But some tests theoretically can be done on site.
Theoretically you can do some testing, but
that's case per case, I guess.
You need to try to isolate your equipment from the environment so that you only measure the equipment which are you interested on to know the emissions.
It's a kind of specific Faraday cage then?
Yeah.
Yes, it's covered with Faraday tiles and electromagnetic absorbers.
You simulate an open space, huh?
We simulate free space.
That's actually what you are doing, yeah? Yeah.
Right. Okay. Thank you very much for the interesting presentation, guys.
Okay.
Thanks.